Didn't we do an episode on this already? Hey, welcome back to Frank's Model Works. I'm Frank. We did kind of do an episode on printing bodies. It was in the early days of my 3D printing experience. I've picked up some stuff along the way that I wanted to pass along to you. On the subject of 3D printed kits and bodies in general, it's going to, in the future, become a growth segment within our hobby. I want to start off by saying, because me saying this is going to dictate whether or not a lot of people stick with the video. Do I think the 3D printed kits that you download, do I think that they're going to replace injection molded kits? Absolutely not. I think 3D design and printing is going to assist plastic kit manufacturers in their manufacturing goals. Yeah, absolutely. I think it's going to start to, it already has played a big part. But as far as replacing them, no chance. In no genre do I think that would be the case. Like most things in the aftermarket, 3D printing is most likely just going to be another avenue of enhancing existing plastic kit manufacturers' products. As far as molded resin, I don't think it's going to replace that either. I think it might fill some gaps that are left as molded resin manufacturers retire. That could be a thing where they might be replaced by 3D printing, but I don't think it's going to replace that in total. It's again, like plastic kit manufacturers, I think it's going to be something that'll complement it. So I just wanted to get that out of the way before we get into the topics at hand here, which is printing better 3D bodies. I'm also going to give you some tips, because I realize not everybody's going to buy a 3D printer. I get it. But you might want to, at some point, buy a 3D printed kit. So I'm going to give you some tips on what to look for. And it's important because there's some raw, hot garbage out there being sold for not cheap. I bought some of it before I knew any better. So I want to make sure you have at least a good idea of what you're getting yourself into if you're going to buy a kit from somebody. I'm not going to name anybody. I'm not going to talk crap about anybody in particular, and I'm not going to promote anybody in particular because I don't really know who's out there printing. I'm at a point where I'm not going to buy from them anyway because I'll just print my own. But I'm going to give you some solid advice on what to look for. But the one thing that we should probably do is define terms. So as you see on the thumbnail over here, when you're looking for a good quality 3D print, you're going to look for something that has a minimum of print lines. The way that 3D printers work is that they expose a layer of resin microns at a time to ultraviolet light, which cures them. That process, if your resin isn't calibrated properly and you're not exposing your resin at the right exposure time, could result in a highly textured print. Calibration of resin is very important. I did do a video on that. There will be a link in the description. So if you're trying to print without calibrating your resin first, stop. Go watch the videos. Go watch every video you can about resin calibration and then come back. But what you're going to find when you're printing a body, which is one of the hardest things that you can print in 3D printing, especially within our genre of car modeling, is going to be printing a body. One of the things we run into the most is Z-shift and print lines and how to get rid of them. So I'm going to put you up there. I'm going to show you examples of Z-shift, and I'm going to show you some examples of print lines because I got a lot of those. All right, get up there. Before we go any further, I made a boo-boo, and I want you all to know about it. Throughout the video, you're going to hear me refer to as 0.020 or 0.050 as 2 microns or 5 microns, respectively. They're actually 0.020 millimeters is actually 20 microns, and 0.050 is actually 50 microns. I really regret the error, but not enough to re-record an hour and a half worth of footage. So, sorry folks. My bad. It's important to define the terms for the things that we're trying to eliminate to produce better prints. And one of the first ones that you'll see is build lines or print lines. Those are these lines that look like topography. You could see them in the roof of this. It's supposed to be a 1967 Valiant, but based upon these round side marker lights, I would say it's probably a 1968, but that's not what we're talking about. We're talking about these build lines. This was actually the first model car body I ever printed when I first got the 3D printer, probably, wow, going on almost 10 months. It did not come out well, but I considered this at the time a success because it actually was shaped like a car. It wasn't until later when I started really diving into eliminating print lines and trying to get good, decent prints of a superior file like you'd get from an Andrey Bezrodny model. I realized I needed to do better. Now, if I recall, this car was printed at a relatively shallow angle relative to the build plate. So the print lines themselves are a function of the layer height that I was using at the time. This was printed at a 0.050 millimeter layer height. I hadn't really I understood the concept of resin calibration, but I hadn't really done it well enough yet. So this became a comedy of errors. But I held on to it because I always wanted to be reminded of where I started. So at some point, if I ever get to printing decent bodies, that I have this to look back on. This, coincidentally, is very similar to a model I once bought off of eBay and paid a pretty handsome sum, but we're going to talk about that in a minute. So that's print lines, and we're going to talk about ways to mitigate the appearance of these print lines and talk about the trade-offs in getting rid of them. The other thing that I was talking about is Z-shifts. So a good example of a Z-shift can be seen in this 1973 Chevy, and there it is right there. That's a Z-shift. So because of the length of this car, I did put it at a fairly steep angle in order to print it, which turns out in some cases to be beneficial. And we're going to talk about a couple of terms once I've defined what it is we're trying to get rid of. But Z-shifts are basically lines in the print that are created by the model itself moving around as it's being printed. There's more evidence of it here. You see it. You'll tend to see Z-shifts below a certain belt line in the model for reasons that I'll describe in a minute. But I just wanted to show you what I mean when I say Z-shifts, and there they are right there. You could also tell the angle at which this body was printed by the angle of the Z-shifts relative to the body. So this body, as you would see it, was printed probably at an angle like that. And again, that was to get it on. I was probably trying at the time, this is several months old, I was probably trying to get the body and a couple other pieces onto the build plate to save time. We're going to talk about why that's not necessarily the best idea. So now that we have the idea, an idea of what we're trying to get rid of, let's talk about what causes it, and finally, how we can get rid of it. Now we're at the part of the video where I have to make a little bit of an asterisk and a caveat. The information that I'm going to give out doesn't necessarily apply to every single 3D printing instance. It doesn't even apply to every single model car body. There are people who, for commercial purposes, print out model car bodies and sell them. They might take what I'm about to say as an offense, or at the very least, they're not going to like the fact that, you know, somebody who they might not think is an authority on the matter, and I'm not claiming authorship on the matter, but they might see anything that I'm about to say as a risk or a threat to their business, and that's not the case. But before they do so, and in general, people, especially for whatever reason in the scale modeling community, won't wait for somebody to get their entire point across before making a negative comment. If you're going to do that, you should realize something. Number one, whether you make a positive comment or a negative comment, you're increasing the engagement of this channel. So you're just helping me by making a negative comment. You could do all the thumbs down you want on every one of my videos. Engagement is engagement, and I'll get fed to the algorithm more. Number two, I don't care. If you want to have a fruitful and thoughtful dialogue about this, because I'm trying to find ways for people to enjoy the hobby more rather than attack you personally. So if your response is to attack me personally, I don't care. I don't care about hate mails. I get them constantly. You can make all the stupid comments you want down below. If you're gonna be a jerk, I just hit a button and you disappear. You think you're commenting? You'll see your comments and you'll notice that nobody reacts to them. That's a pretty good indication that I've blocked you. So, armed with that, hear me out, because I'm trying to produce a better experience for everyone. And that includes you. Because if you take the time to listen to what I say, you might be able to improve the product that you're selling. And if that's the case, you might be able to charge a premium for taking the time to do it. So, with that in mind, now that we've discerned what the actual problems at hand are, and the biggest problems at hand in printing 3D bodies are build lines, Z shifts, and trying to overcome those problems. So how does that really start? So the mechanism that's involved with creating Z shifts, this is the build plate for my printer. And the way that, if you're not familiar with 3D printing, what happens on my model of printer, I have what's called a tilt vat. So my right hand is going to represent the vat of resin. So we start with the resin contacting the film between the resin and the LCD screen that flashes ultraviolet light. So that starts in contact with it, and they put in what's called burn-in layers, bottom layers that adhere the model itself to the build plate. As each layer is printed, first it'll be exposed to the ultraviolet light. Then what happens with my printer is the vat tilts away like that for each layer. On other models of 3D printers, the build plate itself will lift up slightly and come back down, allowing more resin to come in. And then as each layer of the model itself is printed using UV light, the model will build up and grow basically out of the build plate itself. So, for the purposes, when you're placing a model on a build plate in slicing software like Chitubox, you're looking at your build plate like this, and the model itself is going to appear like this. So what you're going to do is you're going to try to find an optimum angle so that the model itself fits. So now that's a tight fit for a build plate, believe it or not, because the supports are going to stick off, and eventually, like, it could cause you problems. So you might wind up getting, wanting to place your model at a specific angle. Not necessarily a specific angle. We'll talk about that in a second. But generally speaking, you place the model in the slicing software, and then you place supports onto the model to hold it while it's being printed, and each layer is printed by exposure to UV light. I mean, that's as basic as it goes. In reality, on the printer, the model will first print, the printer will first print base layers that are stuck through long exposure to the build plate, and then there's a slight gap of usually around 5 millimeters, and then your supports will start printing, and the model will start printing, and eventually the model will appear in front of you once the print is over. So what do we do to prevent things like build lines? Build lines, print lines, topography, they're all used interchangeably. The best way to get rid of them is to print at a smaller layer height. So by default, most printers, when you set them up, will tell you to print it like, which is 0.05 millimeters. It's not half a millimeter, it's 5/100ths of a millimeter. So that results in the topography that you're going to see here, especially if your exposure times aren't locked in through calibration. Remember what I said about calibration in the beginning of the video? Please make sure before you proceed that your resin is particularly calibrated. And another thing that I should mention is a lot of times people ask me, because they have the same printer as I do and they're using the same resin that I use, what are the settings that you're using? If you want to use my settings as a benchmark, I'm happy to tell you, but you should realize that you can't just plug those settings that I use in Chitterbox into your setup and expect it to work perfectly because there's one thing that's not being accounted for, and that's the atmospheric environment of where your printer is. So that's what the importance of calibration, because calibration will take into account the relative humidity and the temperature of the environment in which you're printing. So if you want my settings, I'll give them to you, but it doesn't necessarily mean you're going to make good prints. But we'll get into that later on when I start doing the Chitterbox demonstration. So, as for build lines, off the bat, finding an optimal print angle and printing at a lower layer height is how you get rid of build lines. It's really the only way to do it, provided that your resin is properly calibrated. That being the case, the optimum print angle, there are angle calculators out there. I'll try to provide links to a few. There's definitely one if you become a member of Scale Speed Garage. Chris has one on the site that's very useful. It uses a trigonometric calculation called arctangent takes into, without getting too involved because I don't even really understand it myself. You lose me at trigonometry. So it's a lot of fairly involved mathematics involved, and I just prefer to type some stuff into it and let it spit out a number that I'll then follow to go along with. But for printing bodies, the optimum print angle using the arctangent method isn't necessarily going to produce the best results, which we'll talk about in a second. But the elimination of build lines, topography, print lines is a function of a smaller layer height with an adequate exposure time. So we'll keep that in mind. As far as Z-shift is created because of two things. The tension involved, if you remember. In the case of my printer, the resin vat tilts away. That movement right there, where it becomes unstuck, the layer that was just printed, where it becomes unstuck from the resin vat and the film, that like it actually makes a sound. You'll hear it pulling away. That tension can move the model and shift it around so that it's imprecise. And when the vat comes back up, there might be an offset that creates a shift. That shift creates visible lines in the model that you're printing. So how do we prevent that? You print at an angle such that you're reducing that tension. So if you're printing one layer that is basically the entire perimeter of this car, that's a lot of surface area to be printed in one layer. That surface area creates tension and friction. So if you reduce that tension and that friction, there's less of that pulling force, which could potentially offset your model on the build plate, creating a Z shift. So how do we correct for that? You present the smallest cross section possible while still being able, and this is the important part, to support the model and stabilize it onto the build plate. That's a function of the supports that you put in when you're slicing up. Now this is a big, it's hard. I realize if you're lost. I'm going to demonstrate it in the slicing software right now. Give you a better idea of what I'm talking about. Okay? So just to reiterate, to get rid of build lines, print lines, topography, smaller layer height with properly calibrated resin so that you have the correct exposure time given your atmospheric conditions. To get rid of Z shifts, you're printing at an angle to reduce the amount of tension as each layer is pulled away from either your resin vat or as your build plate moves up, depending on the design of your printer itself, while simultaneously adequately supporting the model being printed such that the amount of shift and it's stabilized enough so that the amount of shift is negligible, if not completely eliminated altogether. Okay? That, and if you're gonna tell me I'm an idiot, be nice, because I'll get it and I'll ignore you. So let's look at Chitterbox. Here we have our Chitterbox environment. I'm going to open up a 1970 Plymouth Valiant 2-door that was designed by Andrey Bezrodny. And as you see, once I hit open, body's gonna pop up onto the build plate. There it is. So we can move around and we can see what we're looking at here. So if I printed this body as is, now keep in mind this is going to be hanging upside down, but you'll be able to see the way it would print. So that would, just like that, at that angle. So things are looking good once you're there. Now you have a lot of surface area being printed, and that's going to create a lot of tension. So how do we relieve that tension? We try to increase the angle while simultaneously properly supporting the model so that we can have the most stable platform for this body to be printed. In doing that, we want to also make sure, I like to print my bodies even though it's gonna take longer. 7 millimeters off, and then in this axis I'm gonna rotate the y-axis, which is green. Let's try that at, let's start with an arbitrary number of 35 degrees. So let's take a look and see how that's gonna print, what we're looking at in terms of cross section being printed at any time. Keeping in mind that the way that the body prints, these will be the last layers to be printed, and the layers over here will be the first layers. So let's see how that's going to print. Now I'm leaving out the come on. All right. So let's look at what you see on the build plate is the cross section of what's being printed. So that's not a lot of surface area, therefore it's not a lot of tension. So we have a little bit coming up now. It's getting a little bit bigger. It's not necessarily growing very quickly, but that's what's being printed at one time. So what we've done by putting it at that angle is we've reduced the overall surface tension of this, which we can now, if we look at that as it's going to print. So that's a larger footprint, and it's just getting bigger as we go. So that's a lot of surface tension. Look at that layer right there. That's a lot of surface tension, and it's not evenly distributed along the model. So if you're not stabilized properly with this amount of surface tension, you're definitely going to have problems with your print. So now things will start to get a little bit better as we get up here. But that's basically why you see, if you see Z shift, you're gonna see it almost always in this area below this, let's say this character line. Why is that? Because, and I'll show you why. Let's put this at a, oh, let's just go right into the support dialogue. These are my settings, which I'm gonna give in a little bit. Let me put my phone on mute because the world knows that I am recording, so that's when they choose to get in touch with me. So I'm going to hit auto support, and I'm going to show you what happens when you hit auto support. So it looks like, wow, there's a forest of supports in there. And there are a lot of supports. It looks like this is a really well supported model, and this is going to print really well. Fortunately, I'm going to reduce the size of these. What's that about? I don't see any supports along the side. Over here, I don't see many in here. Is the other side like that? You betcha. So why is there no supports in here? Here's your answer. Cause of this error. You see that tuck under in this, on the profile? How the body tucks under below a certain point? The slicing software can't place supports here. The programming doesn't really allow it. And if you notice, if I go in here to add them manually, see that red? That means I can't put one there because the software can't build a support up from the build plate all the way over to here. For whatever reason, maybe it's a limitation of the firmware of the printer or the slicing software itself. But in this spot right here, you can't put, like right there, I could put one. And along this line, I'll be able to put one. But say it stops. So, what's going to happen if we print this body? because of the angle that it's printed at, you're going to see lines in this. Now, you see that black line? That's the, picture that as the sweep of the line that this body is going to print at. You're going to see stacked lines, almost like sedimentary layers in this area, until such point that we get to around here, because there's really a lot of supports in there. So that would be relatively stable. So what do? How do we fix this? We clear everything. We go back. And we introduce a smaller cross section by increasing the angle. So let's call that number an arbitrary number. Now keep in mind, a 1970 Valiant in 1/25th scale is not an especially long vehicle. And when I'm doing a print of a body, I try not to screw things. Like, you add, the more ingredients you add to the mix, the greater the problems you might run into. So I tend to only print bodies on a build plate. When I'm printing a body, it's just going to be the body. I'm not going to bother trying to put the hood on, because it's just, time isn't really of the essence if you're trying to create something that's really good. You know what I mean? So we place that arbitrary angle of 35 degrees. Let's go back over and see what happens. Okay. We are, stand by. What's my height off of the, yeah, this happens a lot. Now you'll notice in Chudo Box, even though I put in 7 millimeters of lift off the build plate, it gets taken out if you alternate between the support screen and the placement screen. So let's put that back in. Now, if you look over here, it's saying this is going to take 10 hours. Well, we're going to talk about that in a second. So let's go back over and we'll place our supports. Let me hit auto support. And what you're going to find is there's still going to be no supports in the inside, on the sides of the model. And that, again, that has a lot to do with the shape of the tuck under of the body. So any body that you're trying to print that has tuck under like that is going to have a almost complete total lack of support inside the body here. So we have to add it manually. But we still have the additional problem of not being able to add supports. You see the red? Add supports in certain places. So what are we going to do with that? Well, I'm not going to bore you by making you watch me put supports all literally anywhere I could put them on the inside of this, because that's what I'm going to do. But what I am going to do is come back and I'll show you, after I've added these supports, I'll show you how I did it and what I focused on. In addition to not just placing supports on the sides, I'm going to add as many supports as possible to the bottom, which this looks pretty, I mean, I could probably add a few in here. And then I'm going to show you what sometimes you're left doing in order to do that. So hold on a second and I'll be right back. So as I'm manually placing supports, I realized that I had my support settings set to light, set to heavy, and that's not going to be useful for you. So I cleared all of the supports out and I redid it with light supports. So take a look at what that looks like. Come on. Now it does definitely place the supports more sparsely, but I'm going to show you how I set my supports, the settings on them, because that's an important part of the equation here. I am going to be placing them like I said I would. You could use heavy supports. It's probably not going to work very well. But what that does do is it does give me room to really get, you see everything in orange here? That's basically more or less flat to the build plate. So you want to get some supports along these bottom lines here. They're going to be a lot easier to clean up than Z shifts. So I'll return when this is done, and it does take a fairly significant amount of time. You could be at this for easily an hour. So I'll bring you back in once that's done. Coming back in to show you. Now you see this little, notice how this cone is slightly larger than this one. This is not going to be a support that will, when it's a small cone like that, that support is going to stick out a little bit. There'll be a little ball, and then there will be another cone that comes down and touches around here. I'll show you that after this prints. They're not as stable as one of these, because a cone like this is going to reach down and go all the way down into the build plate, which will add more stability. But it is a support. So in this little small tiny area where a lot of Z shifts develop, you might want to put as many supports as possible, even if it means it's these little dingleberries that stick out. So as you get closer to the tuck under, you're going to see it's going to start to turn red, but that's going to be more up here. Where is it? See the red? See, it will not put a support there. When you see that red cone, it just won't put one there because the tuck under of the body is in the way. So we might have to, I'll give you a little sneak preview. In these areas where you can't put supports on the inside, we might have to put supports on the outside. Don't worry. There's a method to my madness, and my settings for my supports might not make that such a very terrifying proposition. So hold on, we'll be back. Having added the supports to the inside surfaces wherever they would fit, including even putting the nubs, we could see that there are some areas that aren't supported. And even though I added supports as many as I could around the rocker panels, inside the wheel well openings, it probably won't be enough to prevent completely Z shifts from occurring. It's going to mitigate them substantially, but what I've found is, and this is unfortunate because it adds cleanup time to the body before it could be primed and painted, but I have found that putting supports in areas, particularly in the lower body, by the time the print makes it, let's say, beyond this belt line, there's enough supports inside on the body itself where you're not going to get a lot of Z shifts. I've never experienced Z shifts this far up. Definitely not in the roof. Every once in a while you'll get one that starts down here and will work its way up. But again, that's usually a support issue. And I realized that when I first did this and I showed you I was using heavy supports, and that I since turned over to light supports, a lot of people will recommend that you put heavy supports in certain strategic areas. I don't think there's anything wrong with that. I tend not to do it because heavy supports also leave heavy remnants of their existence. The object would be to leave as little evidence on the body of the supports when the body's finished printing. Unfortunately, heavy supports and even medium supports, by their nature, have to penetrate deeper into the body itself, so it becomes a little bit problematic. Now, what I'm going to do is I'm going to show you the settings for my supports. And of note is this particular setting right here. This setting right here. The depth that the supports themselves are embedded into the surface, which is not very deep at all. So the depth themselves are not very deep, and the footprint of the supports are 0.2 of a millimeter. So it doesn't really leave a really big pock mark, but it does leave a mark. And I'll show you once this body is printed the marks that it's going to leave. But what I'm going to try to do is minimize the amount of, and I'm gonna put up a graphic of these support settings so that you have a better idea of what I'm working with, and you'll see what I'm talking about once the body is printed. But what I will do is I'll go to the body on the outside and I'll place supports. So this is what it will look like after it's printed. You'll notice that there are already a couple of supports coming up to the outside of the body. You see that coming up to the handles. And that was placed there automatically by the auto support feature of Chitterbox. So what I'm going to do is, since I wasn't able to really adequately support the body in this lower body area, which is basically the curl under, the tuck under of the body, as seen from this view. So underneath here, we couldn't get supports in there that are going to really mitigate our Z shifts. We're going to have to put a few on the outside, but we should do so sparingly. And what I'm going to try to do when I place the supports, I'm going to try to avoid character lines like this, panel lines like this, and I'm going to try to place them in areas where on the inside we could see, like in here, we couldn't get supports, in order to prevent Z shifts. And we want to use these very, very sparingly, just to provide a level of stability that will prevent us from, that will prevent the Z shifts from happening in the first place. And that this will afford us the best chance of getting a nice quality print. There goes my dog going nuts. If it ain't the phone, it's the dog. So I'm going to finish placing these and I'll bring you back in. So here we have the body supported with the added external supports placed. And like I showed you, they generally coincide with the areas where, because of the tuck under, I couldn't add supports on the inside. Now, the next part of the puzzle we need to address are the burn-in layers. The burn-in layers are the initial layers. I don't use rafts in my print, but each of these supports does have, if you'll see, it has a little piece of, like a little sheet of resin at the bottom of it. For example, like this. Now, your bottom layers are deliberately overexposed so that they will burn in and really adhere to the build plate. The problem with that, you don't want to go ridiculously overexposed. For example, we'll look in my slice settings. So we'll go back to this view. So I'm relatively happy with the position on the build plate And we're in a spot where we can, yeah, that's good. Let's move that over a little. More or less centered and evenly distributed throughout the build plate itself. So if I go into my slice settings, this is where things get a little muddied. So you can see that my layer height 0.020 millimeters. My bottom layer count, those are my burn-in layers. I have 5 bottom layers. And their bottom exposure time is 24 seconds. Where do I get the 24 seconds from? Well, when I calibrated my resin, for my atmospheric conditions down in my basement where my 3D printer is, I found that I received the best calibrated results on the Cones of Calibration version 3. There will be a link in the description, as well as a link back to where I discussed resin calibration earlier in my 3D printing series. So I arrived at 2.325 seconds exposure time for each layer. So what that means is every time I'm printing a regular layer of the actual body that I'm printing are added, and they're exposed to UV light for 2.325 seconds. And you're asking yourself, really, Frank? 325? Why did you go to 3 decimal places? Because 3 decimal places is allowed, and because I'm crazy, I actually arrived at 2.3 seconds, and then I did another calibration test where I convinced myself that I saw a noticeable difference between 2.3 seconds and 2.35 seconds. So I split the difference and arrived at 2.325 seconds, and it has worked for me ever since. Now, this doesn't necessarily mean it's going to work for you on your machine, because, like I said, the atmospheric conditions where your printer is different, and you might use different resin than I use. I use Elegoo 8K water washable space gray resin. So these are the settings that I arrived at through calibrating. Whew. The bottom exposure time is a function where you want your bottom exposure time to be roughly 10 times your layer exposure time in that area without going over. I could very easily set this to 30 seconds, which is, I believe, the default value. It might be 35 seconds. And that might overexpose the layer, the bottom exposure time. Now, the fact of the matter is, and I'm going to go back to my model. We look at this support right here. There's no raft, but overexposing this resin is going to cause it to expand. And expanding it will very quickly take up the 7 millimeters of distance here. And in this area, if we look underneath, there's a lot of supports there. So things get really tight and jumbled in here. And the worst thing you could do is start exposing the resin in here and lose this. You will always, if you overexpose the resin on the base layers, you'll be mixing all of this stuff into this part of the model, and you'll ruin the model. It'll be basically burnt into this part of the car, and it's going to ruin the print. So that's why you don't want to overexpose your bot, but you want to have them sufficient enough of sufficient burn-in time so that the model itself won't pull off of the build plate. And that comes from experimentation, and unfortunately that's part of the rough first couple of weeks that you have with a 3D printer. So now that we've done that, I'm going to slice this model and I'm going to print it. before that happens, well, while that's happening, I'm gonna talk to you about some of the other things that we need to take into consideration and why we take all of these things into consideration, and how you, if you decide to 3D print bodies, or if you decide to purchase 3D printed bodies, what you should look at, what you should be looking out for, and what you should stay away from. So, in the month that it takes to save that file and send to the printer, I'm going to talk to you. What do you want? What's the big deal about Z-shifts and print lines and topography? They're flaws. You want to build a nice model of something, and let's face it, most of the subjects that you're going to get as 3D print files is stuff that you can't get, either in molded resin or in a injection molded plastic kit. I can't see the screen. How you doing? So it's something that you're probably not going to be able to get somewhere else. So you want the best chance of building a decent model of a subject that you want to build. I'm going to put you up there. I'm going to show you the difference between a poorly printed Z-shifted body or one that has build lines all over it. And I'll show you one of the other things that you got to worry about when not supporting your models well on the build plate. So you're going to be going back up there. Yeah, it's a long one, folks. It's one of my barn burners. Sorry. First and foremost, with build lines and topography, they become global. It's not just one section of the model that's going. You can look and see as the light reflects off this thing, it's not just the roof. You got to get in here. Then the surfaces over this grill right here, you're going to have to, look at that. That's a swift pain in the neck trying to get rid of that. You got to get in here and get rid of all of it. In here, it's also in here. Coincidentally, this is the perils of over exposing once you've gotten your model off of the build plate and you've cleaned the resin off and you overexpose it. You could get delamination, which happened to this. I mean, this body's never going to be used for anything other than a cautionary tale. But topography and build lines are literally on every single surface. I tried taking them off the side. This is after, I would say, 2 or 3 hours of sanding. And eventually you're going to sand off detail. I think I already sanded off because the molded in was the Pentastar that's usually on the passenger side of Mopar cars of this era. So that's gone. I would eventually have gotten to the door locks, although there shouldn't be a door lock on a rear. Okay. That's something I got to keep in mind for later. Oh boy. Here's a Z shift right here. These are difficult to get rid of. I'll show you a really good example of a Z shift. That has an actual ridge. You know how hard that's going to be to get rid of? Hours and hours and hours and hours. Now, otherwise, with this model, I had avoided the topography and the print lines. You might actually even see in this body, if you look in this area, there's lines that intersect. That's the mesh of the model itself. This is actually such a high resolution print of this file that you actually see the mesh of the polygons that went into making this 3D model, which I kind of like, because that means that's the hand of the artist. That's actually Andrey's work that I'm looking at there. And although if I use this body, and I probably won't because I did print another one, but that's Andrey's hand. That's his work. And it becomes very interesting. But if you could produce a better version of it, this is a body that this one has had supports added to the outside. You'll notice the lack of Z shifts. You'll notice a lack of typography and build lines, and it's straight. And the biggest cautionary tale against poor supports is in this body right here. Now, this looks okay, but wait a minute. What's going on here? This body's caved in, and you can see it right there. You see that dip? How it dips in? This body's unusable. There's no supports on the inside. It was before I realized that you needed to put supports on the sides of the bodies. So this body wound up being unusable, and when I reprinted it, because of the tuck under, I couldn't place any supports there. So I wound up putting supports on the outside, but because of placement, that's going to be tough. There's little witnesses of the supports. And this was also before I changed my contact depth on my support settings. So there's little bumps on this. Is this body usable? Yeah, but not without significant work. So I might probably wind up printing this again if I ever go to build this file. So, having showed you what can be done and how you can fix the things, let's go back over there. Hopefully we got some results. But before we get results, I'll talk to you a little bit more. Hold on. It's still saving. I filmed that last thing up there showing you. It's still saving. Might be time for a new computer, Frank. So, if you're not going to 3D print and you want to maybe purchase a 3D kit off of somebody, these are the things that you should be looking for. You should be looking for print lines, typography, that. For the reason that I showed you, you're going to be doing a lot of body work if you have something that's got a lot of build lines. If you have something that has Z-shift, you should realize that's going to be very difficult to remove. That is severe body work that's going to need to be done. That's going to add significantly to your time before priming. And not for nothing, there's no such thing as a cheap 3D printed kit that has a body and all the stuff that you're going to need. There are some good folks out there selling high quality prints, and my hat's off to them. It's not my place to send people in any direction. I'm gonna stop doing that because it's turned into a little bit of a headache for me, especially if people get scammed. Then I get blamed. So I'm gonna do less of pointing people in a particular direction. But what I do want you to know, if you are in the market to buy a 3D printed kit, you're going to want to see high resolution pictures of the finished product. And if the finished product displays like a badly textured body, then that seller is probably printing at a very, very high layer height, not necessarily well calibrated. They're trying to crank them out, which, all right, fine. Price your products accordingly. That body, that Valiant that is eventually gonna be ready to be printed, that's gonna take, it says 10 hours and 4 minutes. It's gonna be, once it gets to the printer's probably gonna say 14 hours, and the reality is it's gonna take about 11 hours to print that body, which I'm going to do overnight. It's not like I have to sit here and watch it. I can't see if it's failing anyway. It doesn't make, there is an option where I still have to come down here and watch, and there's nothing I can do. Once it's printed, it's printed. What's going to happen is going to happen. So 11 hours from now, hopefully I'll have a nice Valiant body to show you. But when you print it, adds significantly to the time that it takes to print things. But you get a really good quality print. And I understand if you're trying to do this as a side hustle or as a full-time gig, and you want to get as many products out the door, it's only a matter of time before it catches up to you. Word's going to get out that these things, these things aren't that good. And there's only so much you can do in the comment section of YouTube to prevent that from happening. Yeah, you might get 3 or 4 of your friends to trash my video, but when push comes to shove, you start trouble with me, I start trouble with you right back. Be careful. Be careful if you're going to be buying a 3D printed kit from somebody. Andrey Bezrodny has a Facebook page. It's called CoachBuilder_UA. That's where he hangs out. That's his group. You can see his models as they come out and as they're released onto Cults 3D. There are people in that group that print, but you also got to keep in mind, if you're looking for something to be printed and you say that in a group and then you get a PM on Facebook purporting to be somebody, be very, very cautious, because that's usually how a scam starts. Or if you go onto one of those Facebook groups and you ask for a specific file, you're going to get a PM from somebody who's going to say to you, if you send me $150, I'll draw your file. You're never going to get that file. It's just not going to happen. Andrey himself is incredibly reputable, and he only provides files either on Cults 3D or CG Trader. Those are the only places his files are available. So anybody private messaging you claiming to be him is a scam. That said, just keep in mind, high resolution photos. Make sure that the person that you're going to be buying a kit off of provides high resolution photos, and pay with PayPal and don't pay with friends and family. You want to have the ability to claw that money back if you have to, because somebody might make a nice print for the high resolution photos and then send you this nickel fritz when they're sending out the kit themselves. You know what I mean? So just be cautious. Things, if you're really in a bind, you could run it by me, but let's keep that to a minimum, folks. You know how tickled pink I am about answering questions non-stop all day long. So with that in mind, that still hasn't made it to the printer yet, because this printer, I don't need the thumb drive to transfer the file. It's sending it via Wi-Fi, but boy, it takes a bit. And it's not the printer's fault, it's the computer. The computer's a little long in the tooth. Maybe I talked the missus into a Frank Temba present, getting a new computer. We'll see. I don't know. It's not looking good. Hold on a second. Now we come to the moment of truth. If I remember correctly, Chitubox predicted this would take 10 hours and 4 minutes to print. When I sent it over to the printer, as soon as I started the print, it estimated 14 hours and 52 minutes, and the actual print time was 13 hours, 41 minutes, and 41 seconds. So, let's see what we got. It's not going to lift up much more here. Put the little tray. It did use a significant amount of resin. It does look complete. Not really seeing, there's a little bit of a Z shift, but it doesn't. There's a little bit of a Z shift right there. So let's see what happened. This is always a tricky move. We're over in the part of the shop where I usually address you from is right there. This is more of where I do live casts and podcasts and stuff. So this might look a little weird. We are still in the workshop. just so we're clear. I got the build plate off the printer. I dislodged the model from the build plate. And it looks pretty good. It looks pretty good. You can't tell really fine details until after you've done your finished processing. And in my case, what I like to do is I have a dirty tank and a clean tank. So my first wash will be in this tank with the dirtier water of the two. Don't get me wrong, I cleaned them both at the same time, so there is a point where where they're both clean. Just this one is the first one off the print. And I'll do this one for about 9 minutes in the sonic washer. There is water in there. This is water washable resin. I've mentioned that before. So I do 9 minutes in there, then I take it out and I put it into this tank for about another 4 minutes, just to make sure I'm getting as much of the resin, uncured resin, off of the body as possible. Then I'll blow it dry with my compressor, and then I'll put it in the curing station. I'll bring you back for all that stuff. Hold on. So while that's cleaning, you might be able to hear like the whine of it in the background. I like to clean off the build plate. This has already been washed with Elegoo detergent. It smells like vinegar. And 99% isopropyl alcohol. Now I do realize that this is water washable, and it is being washed in water. But my initial sprays off of the printer onto the pieces that I'm processing are done with the detergent and the alcohol. You can wash water washable resin in alcohol. Doesn't really bother it too much. It's just, what's the point? It defeats the purpose of having water washable. Water washable resin does have less fumes, which is a big consideration for me because I live with other human beings. And although I do mitigate the amount of fumes that get into the atmosphere down here, I want to work with materials that are less reactive. You'll notice I'm not wearing gloves. It's that much more mild. I'm not saying you shouldn't wear gloves. I'm just saying I often forget. So don't do as I do. Do as I say. It is a good practice to wear gloves but I haven't really. I've gotten my workflow down to a point where I don't really touch uncured resin. So, make sure that this is wiped down completely. It is a little bit of a pain in the neck getting in here to clean it off, but I'm so used to it at this point that it's not a big deal. Alright, I should probably shut up because this video is already over an hour long. I'll bring you back. I got the body out of the tanks. I did both wash cycles in the dirty tank and in the clean tank. And it's gotten most of the uncured resin off, but I do want to hit this with some compressed air with my shop compressor. Remember what I told you before about putting, making sure things don't get plugged into the wrong outlet so you don't cause a circuit breaker? Well, the outlet for my pool filter is on the same circuit that everything down here is on. And if the pool filter is on, and the compressor goes on, it blows the circuit breaker. And I have a print going, so it's going to ruin that print too. I could just very easily go upstairs and look and see if the pool filter is on, or even call my wife and ask her. So rather than do that, As it would turn out, the pull filter's not on. That's good news. So, if you see, we have the supports that are printed on the outside. My recommendation is, rather than just twist this body off, because if you just try to twist the body off the supports while these outside supports are on, it's going to scratch. And the scratches aren't a big deal. It's just one more thing, because after I get this off the supports and clean the inside and the outside again to get any uncured resin off, I'm going to cure it in the curing station. And those scratches get deeper because of the curing process. They won't lead to fracturing necessarily. They just become a pain in the neck. So what I do is I keep a pair of nippers close to this part of my workshop so that I can just cut them at the base. They're all on the outside, so they're easy to get to. And then I pull them off very carefully. So I'm cutting these on the base. Just to make sure that I have no surprises. Put the work in to get the best possible body you can get. Model car body, not this body, because I think it's pretty obvious I don't put any work into this one, that's for sure. Yeah, I realized, I apologize a lot for the length of the videos. Could I edit this in so that I could bang out a 25-minute video for you to watch? Yeah, but there's a good chance you're going to have a lot of questions. And I don't want you to walk away from any of my videos with questions. I want to be able to answer your questions before you need to ask them. And since this is a growth segment of the hobby, I want to make sure people get as much information as they possibly can. So we could come in, lightly pull that away, and we take our time. So I'll do that. I won't bore you with that, and I'll come back and I'll show you how we get this off the rest of the supports. Alright, hold on. It's off the supports. It's looking okay so far. I still have a little bit of cleaning to do on the inside, but look at that. All of that is basically waste. So, and there's really nothing you can do with this. It's not going to be useful for anything. It doesn't bend. It's got, you know, bumps and little things that come off it. I guess maybe you could use it to make, I don't know, trestles if you really wanna, but it's waste. And this is probably twice the amount of resin as is in the body. So from an economical standpoint, it would behoove you to buy your own printer rather than get into the business of printing bodies, because this is the waste of one body. The waste of printing one body is 2 bodies worth of resin. Think about that. It also explains why the cost of buying 3D printed bodies is relatively high. Look at that. And it wasn't, this is not it's not a perfect print. There is a very slight Z shift over here, which I believe is going to correspond with the time that somebody turned on the washing machine and going through its spin cycle. Got a little vibration. Oh, that happens. That happens a lot. Even though I ask people not to do that while I'm printing a body, but okay. I'm going to process this anyway because I think that the Z shift is manageable and the body itself is still useful. But let me finish the processing and I'll show you some details, particularly the little half supports that are still stuck inside here and have to be removed. There's actually supports throughout that will have to be removed, but once I put you back up there, I'll show you in greater detail. So hold on. Here's the body off the curing station as it appears. The print itself, I would say, is definitely usable, but it's not perfect. There are some imperfections, notably Z shifts here and here. That, because they're both in the same spot on each side of the print, and given the fact that they were actually supported from the inside in that area, I am going to say that, like I alluded to in the last segment, this Z shift, which is really not that bad, it's definitely workable. It's something that I could probably get rid of with some sanding. I think this relates more to an event in time rather than a lack of support or surface tension. Because this, if you remember, the body was angled like this, and because it hangs upside down, this part of the body was printed late in the printing process. So overnight, not much was going on, but this morning, the washing machine, which is 4 feet away from the 3D printer, even though they're on a concrete slab foundation of the basement, there wasn't direct vibration coming through from, but it could be sound vibration. That can cause that. Sound vibration, if it's loud enough, could cause shaking. And the fact that it didn't happen literally anywhere else throughout the body, and only happened here, would lead me to believe that this is an artifact of vibrations to the machine and not a lack of support. So it's something that, it's another consideration. I've experienced this before. They were doing road work. I live very close to the Long Island Expressway, and they were doing road work at one point, and they were driving piles into the ground, and it would show up, believe it or not, in some of the prints that I did while that was happening. So this Z shift, given that it's on equally placed on both sides of the body, lead me to believe that this is actually a artifact of a specific time that was going on. Something was going on during the time these layers were printed. And I'm reasonably certain if I isolate this panel, I can work it down, and I'll probably do that. But here are my results. Now, if you remember, I was talking about the little pimples, the little supports. There they are right there, as you can see. They do lend some structural support, but they're not as efficient and useful as a support that will reach all the way down to the build plate itself. They should be cleaned up and get rid of them as much as you can. Now, if you see in here, there's little supports from the top from the fender to the fender well liners. Those will need to be removed. And there's also little supports right here from the vent window. Can you see that? Is that focused? Now it's focused. That little support right there. You can also see the little pimples in there. So all of that will need to be, I'll remove that, and then all of those little supports, and then I'll put a coat of primer on and see where I am as far as what needs to be done to correct this. I reasonably believe this to be a usable body. You could see the lines of the mesh on the side. Let's see if that focuses. If you look in there, you might see horizontal lines going the length of the body. That's part of the mesh of the model. There's little pock marks where the supports were, and they should be very easy. They'll probably disappear under a couple of coats of primer and sanding. So I think we got a usable one. Epilogue. After about 15 minutes of sanding work on each side, you'll see that the Z shift is gone on both sides. There's still going to be a little bit of work that needs to be done to get rid of the very slight witnesses of the supports that were placed on the side of the body. But that's not difficult to get rid of. Some more cleanup. No more difficult than it would be for an injection molded plastic kit, and definitely a lot less than a slush molded resin body, to be sure. There is some lines from the mesh of the model itself that's visible, but nothing, there's just some body work to do. I'm going to declare this a success. And I'm going to make sure that in the future, the washing machine's not on while I'm printing a body. So let me put you over on the tripod. We'll sum up this episode. Nobody, and I mean nobody, can snatch defeat from the jaws of victory quite like I can. And if you're going to screw it up, nobody's going to do it like I'm able to do it. If nothing else, the key takeaways that I want you to have from this episode: if you're not going to 3D print yourself, you know what to look for so that you're a better consumer. If you sell 3D printed parts, there's some, especially bodies, there's some solid tips in here with demonstrated technique. Maybe you could improve your product and perhaps charge a premium for it. 70 Valiants aren't going to be kitted by a manufacturer probably any time in my lifetime. And this is going to be just about the only way to get one, unless you want to undertake some serious scratch building. That being the case, hopefully you find stuff like this useful to you. If nothing else, my modeling career is just a cautionary tale. These are all the bad roads you can go down. I'm willing to go down them if at the end of the day you can produce a result that brings you some joy and some catharsis in the release of the tensions of the day. I apologize for the length of the video, but like I said, I want to provide you with as much information as possible. Information that's useful to you and actionable, so that you have a better time at your workbench. That said, as always, I got Frizzo's back and I got Nick's back. I appreciate your support, and until we speak again, my friends, take care of yourselves and be well.